In this short video, we will learn how to use MATLAB's two commands, EzplotPlot and plot, in order to plot a simple graph of y equals f of x. So let's suppose you wanted to plot the curve y equals x cubed minus 3x squared plus 2x. So first we'll do things symbolically, and it turns out that EzplotPlot can accept either string or symbolic input. So for string input, you just type EzplotPlot and the polynomial, but you have to put it inside a quote. It should be a quote, x cubed minus 3x squared plus 2x, since it's a string. If you have symbolic input, then you would start out by declaring a symbolic variable like sims x, and then giving the EzplotPlot command, but without the quotes. This is now a string, symbolic variable, and MATLAB will plot it. It will decide what interval to plot it over, but you can specify the interval yourself with the command altered as follows. Again, EzplotPlot, put in your polynomial. X is still symbolic. But now let's specify the interval, and we'll plot it over the interval minus 2 to 4. So you put it in square brackets with no comma in between. And EzplotPlot we'll see in a moment how it works. You should also consult the resource differential equations with MATLAB for a lot more information on EzplotPlot and various options that it can take. Okay, so that's symbolic. Now suppose you wanted to do things numerically. Then you first define a vector of values for your independent variable. So let's use the same interval, minus 2, 0.1, 4. So it says set up a vector from minus 2 to 4 in increments of size 0.1. And then you issue the command plot x. And now here, but what you have to put in here is the polynomial, but you have to put it in with dots as explained in differential equations with MATLAB, because x is a vector, and when we multiply or exponentiate, we want to do it coordinate-wise. So what you put in here is x dot exponent 3 minus 3 dot star x squared plus 2 dot star x. And that will plot the curve numerically, and we'll see again in a moment how that works. And again, you should see differential equations with MATLAB for lots more information about the plot routine and various options. Before we evaluate, you might think, how do you choose between the numerical and symbolic routines? And typically, if your function or graph arises as a consequence of a symbolic computation, so let's say symbolic, for example, as a consequence of using dsolve, then you would use EzplotPlot. On the other hand, if your function or graph arises as a consequence of, say, a numerical operation, like ODE 45, then you would use plot. Okay, let's now turn to MATLAB itself and see how these commands work. Okay, now we're going to learn how to use EzplotPlot and plot. We first do symbolic plotting with EzplotPlot. Here we are. First I'll use string input, and you'll notice this is just as it was on the previous page. I'm EzplotPlotting the cubic polynomial. Let's run it, see what happens. Here's the plot. MATLAB decided to plot it over the interval -6 to 6, and it gives the little title up here, which is basically the polynomial that it's plotting. That's easy, huh? Okay, now let's use symbolic input. Just for variety's sake, I changed the variable name to t, but I defined the symbolic variable and I easy plotted it, and let's see what happens. And we get basically the same graph. Notice the axis is labeled t this time. Okay, now I'm going to change the interval over which the graph is plotted, and here I used -1 to 3 rather than 2 to 4 as I did in the earlier page. Let's see what comes out. You can see the cubic a little better. Right. Okay, now I'm going to plot using the numerical plotting routine. Use the same interval, -1 to 3. Step size of 0.1. Notice this is exactly what we described in the previous page. And let's run it. And we get exactly the same graph as we did before. Okay, just to show you that one can do a little bit more, I augmented the graph by rendering the curve dashed and in red, and I gave it a title. If you look back, incidentally, plot doesn't title the graphs the way, right? There it is, no title. So let's run this one. I'm giving it a title here, and we'll see what this option does in a second. Right, it gives you the same graph, but it's dashed and in red, and notice the title.